So here's an overview of our software system. We have two main programs that run the robot. One of them is the server node, which handles communication and control of the robot. And then we also have a computer vision node here. And this handles detecting the robot and also calculating where the robot needs to go. So over here is where I'll be running the server node. And up above is where I'll be running the computer vision node. And so these are just terminals on my computer, and down here we can see that the server has started. It says socket was free, bind successful. That just means it's connected to the Wi-Fi network, and I'm just powering on the robot now, so we should see the robot connect. Right there. Client has connected, I'm robot1, hello. So now the robot is connected and ready to start receiving commands. So now I will run the computer vision node. And we can see it immediately starts up and starts saying no markers detected, robot lost. But we can see the server has started to communicate with the robot. And so when it can't find the robot, it just sends commands to zero all the power to the motors as kind of a safety feature. And here's our firmware, and it basically just takes in the commands and translates it to power to the motors. And now when I reveal the marker, the computer vision immediately detects it and then starts kind of calculating values for the robot. Right now the robot's motors are not plugged in, so it's not going to be moving right now. And now when I pick up the other marker and place it down, the computer vision knows that that is an enemy or target to attack. And so it draws another line from the robot to the enemy marker. And then essentially the computer vision will try to calculate values for the robot to line up that red line with that blue line. The red dot is where the hammer will hit when it's activated. Now I have plugged in the drive motors. The weapon is still unpowered, but here is a demonstration of how the robot follows the target. Over on the left we have PID control, and this is what controls the angular effort or angular acceleration of the robot. And so that angular effort output, which is the white value, it is essentially converted directly into PWM values for each of the motors. Currently the robot cannot move forward and turn at the same time. How the code works is it lines itself up in the right trajectory and then moves forward based on its distance to the marker. And the PID only controls the angular acceleration. The PID still needs to be tuned in, but here we can see a pretty accurate, a little bit of an overshoot, but then lines up quite nicely onto that line. Now, the robot sometimes disconnects, as we see here. And so when the robot regains connection, the PID kind of messes up a bit. And this is because the PID is calculated on the server side, not on the firmware side. And so when the robot disconnects, the PID just thinks the robot is not working hard enough to turn. And so it continues to affect the angular acceleration. And that's why we saw that kind of jagged movement there.